Today I'm going to be going over how to do problem 6 from contest 3 called More Power. So in this problem you're given an array of n integers, and on the ith minute you can increase some of the elements by 2 to the I minus 1. And then your goal is to make the array non-decreasing as fast as possible, where an array is non-decreasing if each element is at least as big as the last. So in this sample case we're given the array 1765. So one way to make this non-decreasing in 2 minutes is, on the first minute, increase the 6 and 5, each by 1, making the array 1776. And then on the second minute, increase the 6 by 2, making it 1778. In this sample case, the array you're given is already non-decreasing, so 0 minutes are required. So in order to formulate the final solution, we first need to make a few observations. So let's say we wanted to increase a certain element in the array by a certain value. So let's say we wanted to increase the 4 to a 7, like in the end to eventually be a 7, and then increase 5 to eventually be a 10. Okay, so to know on which minutes we need to increase this element by, we can write the difference in binary form. So here the difference between 4 and 7 is 3, which is written as 1, 1 in binary. Here the difference is 5, which is written as 1, 0, 1 in binary. So from this we can see that the first bit from the right represents your action on the first minute. And then your second, the second bit from the right represents your action on the second minute, and so on. So here, this means that we increased this element on minute 1, we increased it on minute 2, and then after that we did nothing, because these are all zeros. So that would increase 4 to a 7, like 1 plus 2. To go from 5 to 10, we would increase it on the first minute, do nothing on the second minute, and then increase it on the third minute. So 1 plus 0 plus 4 would get 5 to 10. So then also from this we can see that the leading or leftmost 1 bit represents the total number of minutes necessary to make this change. Right, so here the leading or leftmost 1 bit is the third one. So you need 3 total minutes to make this change. And then the next observation we need to make is that, say we have two numbers where A is greater than B, right? So it must be true that the leading 1 bit of A is at least as big as the leading 1 bit of B. So as an example, let's say A is 6, which is 110, and then B is 5, which is 101. So here we can see that the leading bit is at least as big as this leading 1 bit. So with this in mind, the problem becomes we want to increase each element by the minimum amount possible to satisfy this condition of it being non-decreasing. So since the array has to be non-decreasing, each element has to be at least as big as the last, right? But then that element has to be at least as big as the one before that, and so on. So basically, each element needs to be at least as big as all the elements before it and including it. So I'll just clear the board for now. So if you start on the left at 1, the largest element up to it is just 1, so it stays at 1. For 7, the largest element up to it is 7, so it stays at 7. But then for 4, the largest element up to it is 7, so it has to become 7. For 5, the largest element up to it is 7, so it also becomes 7. So this array is the optimal array, where it ensures the fewest number of total minutes to make this non-decreasing condition satisfied. So basically all that's left to do is take all these differences between take like each number that you need to increase it by, and then max all of them, and then take the leading bit of that, because that would like the leading 1 bit of that, because that would represent the total number of minutes to create this array. Okay, so now I'm gonna code the solution so you can see the implementation of it. So I'm gonna first just read in the input. Okay, then we need to store, we need to keep track of a few variables. One is going to be the max value so far, which I'm just going to set at the first value because we're guaranteed that the array has positive length. And then we also need to keep track of the max difference, because that's what we're going to have to check the leading one bit for in the end. So and this can be a 0 because the minimum possible answer is 0, right? If it's just already non-decreasing. So that can be 0. And then we need to go through, we can start at 1 because we know the first element can always stay the same, right? So we're just always comparing it with the ones before it. So here we need to update max value by maxing it with the current element. And also a of 0 has already been included in the max value count. So, and then we also need to keep track of max diff. We have to update max diff by maxing it with the current difference, which is the max value so far minus the current value. So now we have to find the leading bit, which I'm going to call max bit. And 0 is, again, 0 because, again, the smallest possible answer is 0. Right? So like 0 minutes is the fewest number of minutes. So here we're going to go through all of the bits. So we actually are going to loop up to 31 because the leftmost bit in an int is just the sign bit. So we don't actually want to care about that. And just to make sure, the largest possible difference is 2 times 10 to the 9th, which is less than the maximum value an int can store. So we know for sure that using int will suffice for this problem. So so for each of the bits, we're gonna check if that bit exists in diff. I mean in max diff. So if max diff and 1 shift I is not 0. So basically what this means is that when you AND two integers, that just ANDs all their bits. So this 1 shift I will be all zeros except the ith bit will be a 1. So if max diff has a 1 on bit I, then this will be non-zero. If it doesn't, then it will be 0. So basically this just checks, does max diff have a 1 on bit I? And if it does, then you want to make an update max bit with bit I. And then at this point we should have our answer. Oh, actually it should be I plus 1 because like when you, on minute I, you actually increase the numbers by 2 to the I minus 1. So if you make this increase by 2 to the I, then that means you're actually on minute I plus 1. So at the end of this, we just need to print max bit. And then I already have a test file with the first sample case, so let's run it. And it was correct answer. So I'm going to change this to system.in and submit it. Alright, and it's correct. So thank you for watching, and I hope you join us again for future contests.